This video is supposed to show you how to find angle measures of angles that are inside of circles. And the question you want to always ask yourself with circle angles is, where is the vertex? To review real quickly some things you do know. You know that the central angle in a circle is when the vertex is at the center. And the relationship there is really easy. The angle is always equal to the arc if it's a central angle. Meaning if this central angle is 83, then the intercepted arc that goes with it is also equal to 83 degrees. Similar to that is the inscribed angle. This is where the vertex is on the edge of the circle, and the relationship you use there is that the angle is equal to 1/2 of the arc. So in this example, this is an inscribed angle that they want, and so we'd say that that angle is equal to 1/2 of the intercepted arc out here, which is 94. And so 1/2 of 94 tells us that that angle must be 47 degrees. Pay careful attention to whether they're asking you to find the angle, or like in this example where it's an inscribed angle that they've actually given you the angle measure and they want you to find the intercepted arc. Use the same relationship though. Just say that the angle, which is 44, is equal to 1/2 of the arc that we don't know. And so to find that arc, if you multiply both sides of this little equation by 2, 2 times 1/2 is 1. And so that tells us that 1x is 88. And so that tells us that this intercepted arc right here has to equal 88 degrees. Again, using the relationship that the angle is equal to 1/2 of the arc. Even if the inscribed angle doesn't look exactly like what you would expect, again, with angles and circles, you always ask, where is the vertex? In this case, the vertex is still on the edge of the circle. So I'm still going to treat it like an inscribed angle, meaning I do angle equals 1/2 of the arc. In this case, they gave me the angle measure of 51, and so I know that 51 is 1/2 of the arc I'm looking for. And so if I multiply both sides by 2 again, 2 times 1/2 is 1, and so 1x in this case would equal 102. So that's the measure of this intercepted arc right here. Now a new relationship that you don't know yet is the interior angle. This is where the vertex of the angle is inside of the circle but not at the center. And so if you see this picture right here, we've got this angle, here's the vertex, it's inside of the circle but it's not at the center. So it's going to be a new relationship. It's going to be that that angle is equal to 1/2 of arc plus arc. Now these two arcs that I'm talking about are the two arcs that are across from the interior angle. So there's this 151 and there's this 76 degree one. So to find the measure of this angle right here, you would say that angle is equal to 1/2 of the measure of 150 plus 76. Which again, I could have switched this order here to be 76 plus 150 because order and addition doesn't matter. To find the measure of this angle then, I would add 150 plus 76, and that would give me that the angle is equal to 1/2 of 226. And then if I multiply by 1/2, I would get my final answer that that angle is equal to 113 degrees. Again, though, this is the new relationship that you need to know, and you'll use it anytime you have an interior angle where the vertex is inside of the circle but not at the center. Here's another example where we have an interior angle, but notice this time I gave you the measure of the interior angle. I'm asking you to find one of the arcs that it intercepts. So I'm still going to use this new relationship right here, but since they gave me the angle, I'd say that angle 84 is equal to 1/2 of, this is the arc that we don't know, plus the other arc that's opposite from it is 68. And so that gives me this equation that I can solve. I would first distribute the 1/2 into these parentheses, and so I'd get that 84 is equal to 1/2 x plus 34, and then I would subtract the 34 from both sides because now I want to get this x by itself. And so I'd get that 50 is equal to 1/2 of x. And the opposite of multiplying by 1/2 is to either divide by 1/2, or you can also just multiply both sides of the equation by 2, because 2 times 1/2 is 1, and so 1x is equal to 100. And so that tells me that this intercepted arc right here is equal to 100 degrees. Another new type of angle, opposite from interior angles, is the exterior angle. This is where the vertex of the angle is actually outside of the circle altogether. That would be an example like this. Here's the vertex of the angle. It's completely outside of the circle. And the relationship that you use here is, rather than angle equals 1/2 of arc plus arc, the angle is equal to 1/2 of the bigger arc minus the smaller arc. So in this example, the angle is what we don't know, but notice that I have this arc of 49 and I have this arc of 145. Both of those are kind of included in this exterior angle. Notice that one of them is bigger, the other is smaller. That's what I'm going to use right here for bigger arc and smaller arc. So I'd set this up by saying the angle, which we don't know, is equal to 1/2 of the bigger arc here would be the 145 minus the smaller arc here would be 49. And this gives me an equation that I can use to solve for x. First, I would do 145 minus 49. And that would give me that x equals 1/2 of 96. Then I would multiply 96 by 1/2, and I'd get that that exterior angle is equal to 48 degrees. Just like with all these other angle problems, sometimes they'll ask you to find the measure of the angle, but other times they'll give you the measure of the angle and ask you to use that to find the measure of an arc. So to show you one last example here, again, notice here's the vertex. It is outside of the circle, making this an exterior angle problem. So we're going to use the relationship that that angle is equal to 1/2 of the bigger arc minus the smaller arc. But in this case, they gave us the angle of 63, and that is equal to 1/2 of, notice in this case, they gave me the bigger arc of 195 minus the smaller arc is actually what I'm looking for. So I'll say minus x. This gives me an equation that I can use to solve for x. I would first distribute the 1/2. And so I'd get that 63 is equal to 97.5 minus x. Then I would subtract 97.5 from both sides of the equation. And so I'd get that negative 34.5 is equal to negative x. It's very important that you see that this negative is still attached to the x. Otherwise, you might be confused and saying, well, why do I have a negative number as my answer? Negative numbers don't go with angle measures. But since this x still has a negative attached to it, you can think of that like an invisible -1. So you actually need to divide by the -1 to get rid of that negative sign. But that also ends up meaning that your value for x is equal to positive 34.5, which makes a lot more sense. And so this arc intercepted between that exterior angle would be equal to 34.5 degrees. So again, that's a review of central angles and inscribed angles, as well as showing you the two new relationships for interior and exterior angles in relation to circles. And remember, the question of when to use which one of these relationships can be answered simply by finding where the vertex is located.